Hello, everybody, and thank you very much for joining us today, and a very warm welcome to you for the forthcoming presentation on virtual twins in megascale renewable energy systems by Dassault Systèmes. I want to ask that if you have any questions for the speakers, then please write them in the question chat function, and I will endeavour to ask your question at the end of the presentation during the Q&A session. Without further ado, let's introduce today's speakers. Firstly, we have Annette Hogland-Donnes, who is the Infrastructure and Renewable Energy Lead for Northern Europe, which means that Annette is in direct contact with renewable energy developers across Northern Europe and enabling them to embark on the journey towards building virtual twin worlds to enhance their real-world business. This also includes the wider ecosystem of stakeholders, OEMs, and infrastructure. Our second speaker is Charlie Duprat, who is the lead for renewable energy industry strategy and solutions, which means that Charlie drives the definition and the development of Dassault Systèmes industry solutions, transforming the renewable energy industry as a whole. So before we begin, let me give a brief overview of what will be discussed today. As you know, the industry is developing mega-scale complex energy projects, and often these are facing business critical challenges such as collaboration between stakeholders, developing resilient supply chains, project replicability, delivering on time and on budget, and digital traceability end to end. So today, Annette and Charlie will discuss how you can build the digital foundation for collaboration, leading to informed, traceable, timely, and communicated decisions, enabling the successful development of renewable energy projects. So wherever you are in your digital transition, you will now be able to hear user case examples of how virtual twins can enable collaboration between all stakeholders at all stages, from design to operations phase, allow you to replicate and use learnings from previous projects and how they are used for onboarding teams and customers, as well as upskilling new workforce. So Annette and Charlie, the floor is all yours.
Thank you, Jonathan. So I'm Annette, and I hope you can hear me all well. And like Jonathan mentioned, we are responsible for driving the Dassault Systèmes solutions to support renewable energy and infrastructure ecosystem. And what we're going to do today was outlined. So I think that really amazed to see all the great interest in this topic. We have over 500 registrants, some live, and of course, some will be watching this and the recording afterwards. So during this webinar, Charlie and I will highlight what the industry is moving from why using virtual twins more into how to establish it and also to deploy it in active projects today. We're going to discuss some of the frequently asked questions and how to build the digital foundation for virtual twins. And then also looking into really targeting how to de-risking projects and avoid running over budget and over time. All attendees, like Jonathan said, are encouraged to participate and fuel in the dialogue, to use the chat function. And at the end, we'll make sure that we have time for Q&A. So the agenda we have prepared for today is approximately going to last for about 30 minutes, equally split between the sections we have here. First, a brief introduction to virtual twins to get everybody on the same page. And then it's time to focusing on going beyond and now onto how. After this, it's time for Charlie to bring us through a live demonstration part and stepping through some of the selected visual examples and highlighting some of the key concepts that we have discussed. And then we'll round off with a Q&A. So the basic idea is to using virtual worlds to improve the real world. And this is especially tempting and interesting as the complexity increases. And as we all see in renewable energy projects, the complexity really is increasing. Design, modeling, and simulating to collaborate on the complex infrastructure projects with multiple stakeholders and throughout the entire life cycle really is the challenge. Now, we all want to achieve faster and safer and more sustainable decisions to de-risk the investments that we all have to do. For those of you who are new to Dassault Systèmes, let me take a minute to get everyone on the same page. We're a French headquartered software company enabling our clients globally to create virtual twins using capabilities such as modeling and simulation, data intelligence, to supporting anything from startups to large corporations. That we do together with a wide ecosystem of partners. Here in the timeline, you see that modeling is taken going from parts over to products, processes, onto systems level, and now connecting virtual twins to universes. In the timeline of a couple of the flagship projects like the Boeing 777 going from 2D to 3D, or the full PLM, product lifecycle management for Toyota, as well as the virtual city and port of Singapore are exemplified. Now, as the complexity and looking for complex projects, moving into life sciences and infrastructure, really to connect those virtual twin universes to address the society scale challenges and to drive sustainability. An important point is that it's all science-based, physics-based modeling, true object representations of all the objects, relations and simulations, not just nice rendering, but an actual system and systems engineering used to test what-if scenarios and prototype products, assets, and business. The 3D Experience platform is represented by the blue compass on the left. The platform is underpinned by brand applications that are clustered into 4 quadrants: the social and collaborative apps, 3D modeling, simulation, and information intelligence. We will not go through the details here, but just for you to see that those are the ones underpinning the platform. And with those solutions, we're targeting 12 different industries, and today we're going to focus on infrastructure and energy materials section. Together with the leaders in these sectors, we align on common challenges to really target the solutions, making sure that they support the industry-specific challenges that are. And in the infrastructure and energy sector, this is to design, model, and simulate and collaborate across the complex infrastructure projects. Faster, safer, and more sustainable investments. All right, so now we're saying that we agree on focusing from why transform to how to do it. So the practical questions arise. Let's take a look at those. So the perfect storm, as we know, full of challenges. New energy, the complexity increases, evolving energy systems, and new business models. And of course, we need to bridge those technical challenges as data in silos and no way to collaborate. We have talked about these before, and the first time we met to work with Jonathan was in September, where we presented a few examples on this. This is still recorded and available online. You can access it with a QR code. Dassault also has a landing page, a power plan for a smooth energy transition, so feel free to access those. And also more ebooks and material to get to that desired virtual twin state. All right, so building the foundation, now on to the how. What's needed? Often we start with use cases. This is a busy slide, but what I want you to focus on is that you see that it spans the entire life cycle from a new project all the way through to commissioning. All the sub pieces in here you can see represent the typical use cases that we meet and challenge and organizations identify as their key topics for all the various users that exist. So the more challenging topics are the ones really spanning the entire state from beginning to end. So how do we get here? This is really the vision state. Now, the key concept of leading this transformation is going from the current state to the target state. So if we all agree, siloed information, point-to-point collaboration. And where we want to get to is to the common data referential. But how do we do that? The key concepts for getting to that transformation are unified referential, object-based, and based on model-based systems engineering. Let's take that with us. This is the part of the transformation that's typically the hardest. The current systems are not designed for interconnectivity and need to change at the core and fundamentally to unlock the target state. This is where the hard work starts. So when we go out and have dialogues with clients in the market, what do we see? It typically starts with looking at the asset lifecycle from beginning to end. Green renewable energy developers have an entire plethora of collaborators and different roles to address, and also an end-to-end responsibility. So what does it look like? Here we go. Mapping the various systems and the information flow, the current landscape. And then also, especially for large infrastructure projects, we have a new group, society and investors, and a group of stakeholders that we need to take into account. So the system landscape, the architecture, the information flow, and then the existing systems. This is a common view. Taking it from here and looking back to the use cases that we want to address and bring into here, mapping those use cases onto this digital architecture. And then, of course, also how to unlock and get from that state onto where you want to be. These 4 stars that we have highlighted here are use cases that Charlie will walk through later in the demonstration. But I will also just show that what we are doing here is to understand which information is flowing to where and what needs to be pulled in and federated in order to unlock the use cases. And then also for the various users, in which format do they want it presented? How do we want to bring the information in context with all the greatness that we can bring into here? So, Charlie, are you ready to take the audience through the live demo that we have?
Yeah.
Now, the mega-scale renewable energy ecosystem of stakeholders, and here are the 4 use cases.
Yep. I'll be taking over from here. Thank you very much, Annette. Following this introduction to our solutions and to the scope we were able to cover, which are, I hope you understand, is very, very wide. Back to this slide. Thank you very much. We're going to show you an end-to-end demonstration that is in no way exhaustive in the coverage of the different scopes we might address. It's really an end-to-end demonstration, taking the lead as a supposedly project developer for an offshore wind farm. It's a mere exposition of the capabilities of the 3Experience platform and the virtual twins applied to the universe of an offshore wind farm project. Now, once again, it's just a door opener. It's just to get an idea, a vision of what could be done through digital transformation of the current ecosystems. And it's an exploration of the vision we have for this industry. So down to it. Jonathan, if you may give me the screen, please.
Yes, certainly. If you share your screen, I'll be able to do that.
Yep. What do you mean if I share my screen?
Share screen function, Charlie.
There we go. Yeah, 1 second. I will just select the right window right here. You should be showing just what I was looking for. Yeah. Right. Thank you very much. Okay, here we go. So again, this is one of the latest versions of our end-to-end offshore wind demonstration. The idea is to explore the way we intend to digitize this industry. What we're seeing right here is what we'd call the unified referential. We're supposedly in the early stages of an offshore wind farm project. We're in the 3Experience platform, obviously, on our web browser. And we're in an actual industrial context. We're north of France, in the Appel d'offres of Dunkirk, right? We can see that on the screen right now. And in the early phases of the project, when discussing with the state, when forming a consortium, when developing the pre-feed and through the pre-feed and feed stages of a project, and when answering the RFP, there's a huge need for coordination and collaboration across a very diverse ecosystem of players that not necessarily work with the same tools, that pull data from different sources. And we know that those phases take a while. They take actually a very, very long time due to the need of collaboration of different stakeholders. The idea is here to integrate different layers of data in a unique environment that is meant to be an early virtual twin of the project, where you can just compile data from external or internal sources, from documents, from survey services, from the RFP itself, from government sources, and so on, and just plug this data in a unique environment and have it support your collaboration internally at the scale of your own company, but also at the scale of external companies and at the scale of the consortium. So we could imagine that we are a project developer and we're using this tool right now as a means to collaborate early in the phase of the RFP, say, to aggregate all the data I've pulled from the field, from the RFP, and from the work of my engineering teams and project teams, and put it in a single environment where everyone can collaborate and access the up-to-date information. So this is really a way here to aggregate data. And what we're seeing is the different layers of data that we've pulled together and aggregated in this collaboration environment. Of course, it's always related to 3D, or it can be at least. So here what we're seeing is an artistic view of what it will look like, what this project might look like. And we know that public consultation is really an issue for this project. It slows it down drastically. Well, this can also be used as a tool for rendering, and in the same environment where you collaborate and aggregate all the data you need, you also have the rendering of the 3D to make sure that you can share information like that with public authorities, local authorities, citizens, and so on, to add yet another layer to the discussions. So the idea here is really to have a unique, centralized referential that is not meant to replace other tools that you might already be using that are specific to a use or another, but to have this cross layer of information that really is a central referential. What we're seeing on the screen right now is that the models are actually there. So we have the GIS data, we have documents, we have requirements pulled onto this map. But we also have our actual physical models and turbine models and everything that's related to the asset itself. So really, this should be seen as a way to aggregate and centralize data in a unique environment. I will fast forward a little bit, and there we go. Now into the next phase. This project remains theoretical. We need to deliver it into the real. How do we do that? Well, we need to plan the project and plan its activities. So in a very typical way, we're going to be doing some project planning, but the difference here is where we remain in the same unique environment. We remain connected to everything we've seen just before. And we have our project structure. We designed our project, we engineered our project structure, we assigned the tasks to our different stakeholders, internal or external, etc. We're managing the assignees, the documents. So here, the real difference in this model-based approach is that everything we do is connected back to the 3D and to our models, to our objects. So the wind turbines and the wind farm asset we've seen earlier on, well, it's connected to the requirements, it's connected to the tasks, it's connected to the project structure. And this project structure can be both external and internal. We have connectors to connect to the best-in-class tools from the industry that we know are very well in place, like Primavera P6, for instance. So it's really a way to aggregate around a unique model, requirements, documents, and every other kinds of data that will constitute what you will make of your project virtual twin. And the whole value is over there. Well, we can see right now a bit more of collaboration, also centered on the 3D. This is our 3D model of the wind farm, and those red dots there are 3D issues. That means basically issues as a core means of collaboration between stakeholders and across organizations you could share issues with your OEM, you could share issues with EPCI general contractors, you could even talk to government entities through this means. So it's really a way to track all activities and to make sure they're all performed in time and on purpose. And like we're seeing on the screen, it's always connected back to our models, to our object through this model-based approach. So collaboration isn't separated, isn't segregated at all from the core model that is the center of your referential. Now, what we're seeing right now on the screen is yet something a bit different. We're now talking about engineering, and this structure, let me pause for just a little while. Here, what you will have on the left-hand side of the screen are the requirements. The real interest here is that requirements can be digitized and aggregated in this unique environment again, without replacing your tools. You can keep using IBM Doors or any other tools for that matter, even Excel, why not? The important thing is you can plug all of that into the platform and have a central referential of digitized structure and harmonized requirements, which is what we see on the left-hand side of the screen. And the important thing is you can use that as a backbone to support any activities, including design engineering activities. And what we're seeing here is the traceability through our requirements onto a functional architecture of the system, onto a logical architecture of the system, meaning components. And in the end, on the final right-hand side over there, it's hidden right now, we've got the physical models, the actual physical 3D design. So what I mean to say here is we've got continuity throughout project phases and throughout facets of our asset, which is really something that's essential to make sure that you design on time, on budget, in an optimized way, making sure that you comply with the very complex regulatory framework that we have to deal with in this industry. And yeah, I'll fast forward just a little bit. There we go. And as always, this is also connected back to the 3D that we can see on the right-hand side of the screen. It's the same asset with the cables, the turbines, the floating structures, the substations, and so on. And this is connected back to the architecture of the system and back to the requirements. And any modification I make will have an impact on such, and I can measure those impacts and make sure that, well, any modification I make on the system, well, results in a system being compliant still with my requirements, which is something essential. All right, so this is about it for the design aspect, and I'd like to switch to a final part, which I think could raise some interest as well. Here, we're now in operations phase. Let me just pause that for a while, and we'll dive into this. We're supposedly in the seat of a project developer / an owner operator, right, of an offshore wind farm. Here is the same industrial context. So we've fast forwarded in time, and we're supposedly in operations phase of our Dunkirk offshore wind farm, north of France. What we have here is something that is complementary to what, well, industrial players already have, which is SCADA, right, to drive their assets and control their assets during operations. And the AEAM, of course. Well, on top of that, this here is a way to imagine how we could use all the IoT data that we pull from the assets, the multiple sensors that we have on the turbines, on the cables, and so on. These huge volumes of data could be pulled back into the platform to have what we could call an operational virtual twin, which is a way to monitor well, the performance of your asset, both technically from a power generation standpoint, and also as a means to collaborate with the involved stakeholders for operations and maintenance. So here, what we're really doing is, well, here, of course, it's simulated. We're pulling data from the field, we're pushing that back into the platform, we're reconciling operational data back with engineering data and, well, former data. And the idea is to have a comprehensive virtual twin to understand every single piece of behavior your asset might have, why it would not be exactly operated as it was supposed to be, why the output generated is not exactly what it was supposed to be, why do I encounter some issues, why do I have some reliability issues, for instance. And the digital continuity offers the possibility to understand exactly this and to take preventive measures or corrective measures if necessary. right? So here, what we have is a lot of metrics, right? I have my wind turbines on the right. I have metrics pulled from the field under the form of comprehensive and visual and quite very, very easy to use and understand graphics and so on to understand the performance and the operational data basically related to my asset. I also have an issue management aspect, which I can see right now, and basically say an inspector on the field or during a maintenance operations or just simple operation inspection maintenance will pull the report because some part was flawed or wasn't behaving as intended, or some corrosion was noticed, something like that. Well, this can all be digitized directly back into the platform, again, as a way to have an operational monitoring tool that helps decision making to improve operations and to improve productivity in the end, right? And again, this is all connected back to the 3D, as you can see right now. This is the same exact 3D model of my asset, except this one is what we would call the as-built model. So this is really 100% aligned with what we have on the field. It takes into account the maintenance operations and so on. And the idea is I have a versatile, evolutive virtual twin that supports operation, that helps me pull data from the field and leverage this data. I filter it and I just expose what I need to make the appropriate decisions to run my operations as smoothly as possible and to anticipate any kind of events to maximize productivity. Right, so I think I'll conclude on that. Again, this is just a glance of the multiple virtual twins that solutions like Dassault Systèmes can offer for operational, for not only operational, for offshore wind farm project development and operations. If anyone is interested, of course, we'll be happy to answer to questions, and we'll be happy to show more if necessary. Thank you very much. Annette, back to you.
Thank you, Charlie. Well done. Great highlights there. Now we have reached the final part of the agenda. I think you're seeing my screen, so questions and answers, time for that. And while we're landing on this page, I'm putting up some of the QR codes, but also Charlie's and my contact details. And for those of you who have meetings to go to or cannot cut your lunch any longer than that, thank you for participating. And for all the rest, we now invite you to use the chat function for questions and answers. And Jonathan will help us moderate this session.
Indeed, indeed. Well, thank you very much to you both for your interesting insights that you've provided in enabling us to see the exciting work that you're doing in supporting the digital transition to build the digital foundation for enhancing the successful development of renewable energy projects. And great to see it in real time, Charlie, as well, with the video presentations. So we have a couple of questions for you both from the audience, but I would like to open the Q&A period up, please, because I've been watching intently. You suggested in your presentation that in order to build the future energy systems, we need to transit from document-based to object-based approach. I just wanted really to clarify, what does this mean and what would I have to do with all the required documents?
Thank you for that question, Jonathan. I can get started, Charlie, if you want, and then you can complement. So this is part of the key transformation concepts that was outlined on one of the slides. So it's really important to understand that documents have been and will be important part of any large infrastructure projects, but the information stored in this document and the way it's used can be accelerated and enhanced. And that's basically the transformation of not just attaching documents, but really ingesting the information and making it object-based. And that will allow and unleash some of the use cases that are not possible if you keep them only in a documents format. So this is the point. Charlie, can you add your comments?
Yeah, I'll add on top of that, 100% aligned with your answer. Obviously, the real change is that where the documents are always going to be part of the game. Certification bodies, government entities, they all require some documents to be sent to them at some point in time to certify that the asset can be operated, to certify certain things. Idea is we're not here to replace documents. Digitalization is not exactly about that. It's about integrating documents in a broader picture, where documents are just a facet, either an input, an intermediary facet, or an output related to a model, right? So you could have technical data under the form of documents attached to a model of your wind turbine, for instance, to just have some notes that are necessary, the document-based requirements can be digitized, but still traced back to the original requirements, because this is part of the chain that is required to be preserved. So really the idea, like Annette said, is not to replace documents, but to integrate that as a part of a broader model-based approach, where documents are really correlated directly with data and no longer just stashed on drives and getting lost or getting duplicated. The idea is to have traceability and manage documents as data, as part of a broader data approach.
Yes, and this is nothing new. This is already taking place in more digital and mature industries. So what we're doing here is to take best practices from there that also and bring them into the energy and infrastructure world.
Great, fantastic, thank you. Very well and clearly explained there. And we have a question from Karen Marie Sandgren, who is the Director and Advisor for the Nordic Energy Connection. She's basically asked, does the value of your system solution depend on users introducing it from the get-go? Or can it also be valuable to integrate even later in a process?
That's an excellent question. Thank you for that. Obviously, if you start with a green or white paper, a blank sheet, you can. That's kind of thing self-explanatory. It might be an easier sale to do, but as a matter of fact, and as reality is, most of us sit in already existing operations with complex data sets and also digital architectures. And the example slide I had in there was really actually showing that, mapping the current state, and the current state is sometimes a jungle as it is. And what we do there is really to start out from there and understand the priorities and work our way to connecting the digital. And some of the projects that we have highlighted on that landing page up to the right-hand corner are examples of that. So you can follow the YouTube links on that page and follow that. And that's really where we're doing. So we're stepping straight into business as it's running today, and then enabling that transformation to go towards a virtual twin, really stepping from today's practices, introducing best practices, but then also to enable the next practices of as it is. So the answer to the question is that anywhere you are in the cycle, it's really the time to start.
Great. Thank you, Annette. Charlie, I have one specifically addressed to you from Nicholas Fafis, who is the Scientific Project Officer at Science Foundation Ireland. He is asking that I see in the offshore wind farm project, it contains geographical and hydrographical surveys. Are these surveys static, or are they updated to illustrate seabed morphology changes as a result of the wind turbines?
Well, that is an excellent question. In the demo you've seen, they are static, because it is just for the purpose of showing what can be done. Nevertheless, we're able to connect to external sources and APIs, among others, that can pull data from external sources in a repetitive manner, right? So the idea is it can be evolutive. It doesn't have to be static. If you have inputs of data that come periodically, you can definitely integrate that. Well, of course, depending on the period, but that is 100% doable. And when talking about everything that's related to the environmental impact assessment, which is something of the utmost importance, of obviously in offshore wind farm development, measuring the changes that have been performed or the impacts that were generated on the seabed and on the area where globally the wind farm is being built. This is something that's required, actually, right? You need to anticipate the impacts, and you also need to measure the impacts once set in place. So this is something we can do. Yeah, plug data from external sources, have surveys performed periodically thanks to sensors or ships people going there and doing their measurements. And this data can be, well, integrated into the platform as many times as necessary to track the impact and track the evolution in time. So it doesn't have to be.
Great, thank you, Charlie. And we have the next question from Mohammed Farhan, who is an O&M structural engineer at Iberdrola Renewables. And he's basically asked, can this provide failure rates of each component by data analysis over time? And can we add manually the data gathered from inspections through your solution?
So if I may, and you can complement if you want, I can answer that one. Let's go one by one. So about the failure rates, yes, it's not shown in the demo because showing everything we can do would take forever. But yes, equipment reliability and even that pushed at the scale of the asset, so asset reliability as a whole is something we can monitor, obviously. It's just an aggregation of equipment reliability in the end. So we can do kind of live fault tree analysis and failure analysis. And recently we've been working on AI-based technologies to do exactly that. So we're relying on everything that's been studied and pulled from the field in the past. And based on that, we're anticipating what will happen in the future, anticipating potential failures to make sure we provide the right level of information to decision makers to make the appropriate operational and maintenance decisions. So yes, this can provide the failure rates for each component by analyzing the data from the field and combining that with data from engineering, for instance. And the second question now was, manually adding data gathered from manual inspections. Yes, we can do that. We have a suite of tools that belongs to our brand Delmia that allows to drive and track the execution of every maintenance activity, including inspections, for instance, typical inspection rounds. So it brings the digital connection down to the level of the field, thanks to mobile devices and so on. So the idea is, if the inspection is performed that way, even if it isn't, but ideally it would, you would pull back this information and reports and flags from the field back into the system, back into the platform, and this data can be aggregated as well to this referential, right? So data can definitely be added manually to the referential. Yes.
Great, thank you. And Hugh Morgan, the technical director of engineering at Copenhagen Offshore Partners, he's basically asked, how does this integrate into use of BIM or BIM in the development phase of the projects?
Charlie, do you want to get started or should I?
Up to you.
I can start. So basically BIM, a description of objects and drawings and data. And like Charlie mentioned regarding any type of data, the platform allows for data federation and ingestion of that data. So it's a very natural step to have any kinds of 2D drawings, 3D drawings, other types of data from external sources that would be consumed by platform and represented in the common data environment that the 3D Experience platform provides. So that's really, if you remember the compass, and we talked about the various apps and quadrants, there you would have those that you can plug in external ones or plug in, but basically we can make sure that data is used as part of it. So quite naturally using that data. Thanks for the question.
Great. Well, we've got 2 more questions, so I will look to continue to ask these. There's a question by Nolan Grau, who is a consultant at a company called Demona. He's asked, for a complete integration, would the tool be needed across the whole support value chain, and the case that some of the processes might be outsourced?
That's a great question also. So if you recall that kind of complex matrix we talked about, where we have at the top regulatory bodies that need certain types of information, then the owner and developers, and then you would have service providers, so on, and the lanes and the lines between those lanes were supposedly supposed to represent exactly that, data flowing across and between different stakeholders. So I think that's really saying that you need to work out how to transfer information in between. And but if the question was to answer, do you need to have Dassault solutions all across that? It's not necessary, but there are early front runners today that we're seeing that are leading the change, that are inviting their collaborating partners to work in the environment and also be integrated as part of the inclusion, but also as part of making sure the digital thread is crept. But where we're starting today, the truth and the reality is that there are bridges between external sources, but also linking into the system. So I think it's, you can say, a matter of maturity and progression.
Yeah, and I'd like to compliment on that. I really like your question, Mr. Grau, Nolan, because this is really where one shouldn't be mistaken. Again, the idea of the Three Streams platform, the idea of the Dassault strategy and vision for this industry is not to replace everything in place, right? There are very, very good softwares already in place that are meant for specific applications. Some are broader, related to project management, for instance. Again, the idea is not to replace that all. We do not have that kind of pretension. Nevertheless, we sense that there's a huge lack of data harmonization and collection across the entire value chain. This is all siloed, and this is what takes a lot of time. This is one of the things that does not help accelerate project development. So you do not need to have the platform everywhere for every piece of the supply chain and for every stakeholder that's in the value chain. That's a possibility, of course. The idea is to have it as a software that underlines the collaboration for all stakeholders. So it's a possibility. You could have it for one single company, for just a project developer, and everyone works on their own environment. Or you could spread it throughout the ecosystem, and it would be, of course, the more you spread it, the more powerful it is. But that's really a question of maturity, like Annette said.
Great. Thank you, Annette and Charlie. So our last question we have is from Karen again. She's asking, are you factoring security and defense aspects such as risks of cyber, physical attacks and vulnerabilities, for example, critical assets and infrastructure, and even potential added costs, such as to add defense features in accordance with new requirements in public tenders, for instance? She said it's a complex question, maybe.
It certainly is a complex question, and I think I can add. So if you remember the slide where you have the key concepts and where we outlined their object-based and there was also model-based systems engineering and systems of systems engineering. Those are fundamental concepts used already in very advanced industries like defense and aerospace, where security and safety has been on the table for a long, long time, and is now also making the way into energy. Of course, Dassault does not provide all the specific data and all the simulation that can be done for these topics, but there are unique players out there, doing these simulations, and that has a massive data collection in the background. But this data can be integrated as well. But I think that the main key point, and that's also what was part of the introduction, is that using these key concepts as object-based and model-based systems engineering really allow you to keep that digital traceability to de-risk projects. Otherwise, having several interfaces where data is thrown over the fence and kind of captured just as whole, that poses a risk. And I think specifically when it comes to the vulnerability and safety that you see also critical infrastructure being exposed to today. Anything to add from you, Charlie?
Well, not really. Yeah, actually, maybe just a bit compared to back to the security, cybersecurity, and defense aspect. Dassault is very much involved in the industry, the nuclear industry, and very much so in France as well. I think that's a very good example of the level of cybersecurity we're facing there. This is one of the more secure industry in the world. And the players we're talking with, the companies we're talking to, have extremely high standards and expectations related to that. So we have developed, adhered to organizations, and we have developed our own solutions to make sure that we have we are able to answer to the high standards related to cybersecurity. So this is something when talking about we're at sea, we're in territories, when talking about energy sovereignty as well. Those are topics that need to be addressed. And yes, we do have solutions to cover that.
Brilliant.
Right. And before, perhaps just as a finalizing comment, Jonathan, I wanted to say, because one other question that we do get a lot is that, so, in my organization, we're firefighting today's situation, and, how do we take time to then also excel and drive these, basically do the transformation. So here I wanted to mention that besides providing the solutions, Dassault can also help with taking and walking through that transformation journey. But there's also an additional key aspect that we can do, and that is to provide the virtual twin as a service forward. So I really want to say that the options are there, but the first thing is to ensure that we have a dialogue and to work out which options would be possible and the right ones for you where you are at the moment. So we really look forward to those dialogues. And again, thank you so much for participating.
Great. Well, thank you ever so much, Annette and Charlie, for the presentation, and obviously as well to you, the attendees, for taking part. We hope this was insightful for you. As you can see on the screen at the moment are the contact details for Annette and Charlie. So please do reach out to them as well as their colleagues at Dassault to see how they can help and support you. I just want to thank you again for your presentation today, both of you, and to the audience as well for taking part. So thanks.
Thank you very much.
Thank you.